just miss school.
Oh. Here we go. So this one's great. Negative 25x equals 500. We have negative 25 times x. So the inverse is division of negative 25. When we divide, we do get x equals negative 20. Great job. This one we distribute. 4 times 2x is 8x. 4 times a negative 6 is negative 24. Add 24 to both sides. Divide by 8. X equals 6. Awesome. Here we are cross multiplying. This is what we were doing yesterday. 24 times x is 24x. 24 times negative 7 is negative 168. But then the 12 times 10 is 120. Add 168 to both sides. Divide both by 24. X equals 12. Questions? Go ahead and get out your homework, please.
Where'd you get that extra
So your homework is a worksheet.
Okay.
I don't know if I did them right. Like I did them, but I don't know if I did.
I love HTTP. They're so
Guys, one more time. Get out your homework, please.
All their shirts are like see-through.
I didn't understand the back side.
Okay.
Yeah, I did some of it.
So, no, did you do all of them?
No.
Okay. Did you come and get up?
Because like for like one, I did it. I like.
Hey, hold it up. Let me see. Flip. Isabel, let me see. Hold it up. Flip it over. There's. Flip it over. Other way. There you go. Flip. Where's the last one?
This is how much is homework.
Where's the work?
Maybe you should just do the book.
Well, I did this part.
People are saying just do the book.
I'm so
Okay, so you hold that.
Yeah.
So you don't need to finish
And
that?
everyone
Okay.
who like, okay, let's just say this. Everyone basically waited, like everyone finished at like the end class. Like they took the whole class time.
Wait, what?
Which like usually people like finish early. So the only person who finished early was Lucas. And Lucas should be in chemistry. Drawing.
Oh.
He should be in like
Okay, here we go.
Can I use the bathroom?
Huh?
Can I use the bathroom?
After I go over this one. And after I go over this one.
Okay.
Here we go. So number one is 12 and 5/10.
Oh.
Number 3.
Wait, is that 12.5?
Yes. Number 3 is 15. Number 5 is 6. Number 7 is 5 and 6700ths, which is 5.67. But if you got 5.66666666, that's the right answer. You just didn't round it. Number 9 is negative 2100ths, which is negative 0.21. Questions on the first 9?
Wait, what was 9?
Negative 0.21.
I got negative 0.2.
That's fine. You just didn't round to the nearest hundredth. 2 decimal places. Number 11 is negative 35. Number 13 is negative 4 and 6700ths, or negative 4.6666666666. But then you had to round.
Wait, what question are we on?
We just did 13.
It was
1 point.
Negative 4.6666666666666666. Number 15 is 30. 17 is negative 146. Number 19 is 10 and 2/10, which is 10.2.
Wait, can you repeat 17 and 19 again?
Negative 146 for 17. 10 and 2/10, or 10.2 for number 19.
Yeah, I did not get this.
Okay.
So,
I didn't get
So
17.
Okay, let's do 17. Here we go. So we have p plus 10 divided by p minus 7 equals 8 divided by 9. When we do this, we are still cross multiplying. So we still have 8 in parentheses times p minus 7 in parentheses equals 9 in parentheses times p plus 10 in parentheses. This is just a equation where you have variables on both sides. Nothing is new. You distribute both sides. That's 8p. That's negative 56.
Wait, does it make a difference if I switch the sides? Because the 8's on.
No, do you mean if they're on the opposite sides?
Yeah.
No, it does not. So now I'm distributing 9p plus 90. So now we're just solving the equation. We combine our p's. That leaves me negative 56 equals 1p plus 90. I subtract 90 from both sides. That gives me 1p equals negative 146, I think. Divide by 1. P equals negative 146. So you just have to distribute. And then
15, let's see, 10x, and then, like, I
Subtract
did
mine.
that.
Well, your x's are all over here. You can't bring them all onto one side. So you've got to get them to the other side. The x's have to be isolated.
I didn't.
So we remove the 10x's so that they're all on one side.
I didn't subtract.
Okay. Okay, go ahead and get out your notes. So we are still going to be using equations, so you can't forget how to solve equations. That sheet that has 6 steps on it, you're still going to need. If you've lost that sheet, you should probably borrow somebody's and copy it down so that you have those steps. Because that's going to be important. Okay. So an inequality means that it's not going to be equal. They're unequal. Inequality really means unequal. So, if I said, your parents are going to ground you if you score any lower than a 70. What's the lowest score you can have?
70.
What are other scores you could have that prove that you're not going to get grounded? 80. What else?
90.
How about a 70.0000001?
Yeah.
Yeah, that's 70 or greater, right?
71.
That's kind of like an inequality. It is an inequality. What if I say, those of you that fail will have a score of 69 or lower? What would be failing scores?
69 lower.
69, 68, 67, 66. What about a 68.2345? Yeah, it's still lower than 69. Doesn't matter about the decimals. So you're going to want to copy these down. This symbol here, this gator mouth, is called is less than. Is less than. This symbol is called is greater than. Okay, you need to know those two symbols. So copy those down. So, if I say the scores need to be less than 101. If the scores need to be less than 101, is 101 an answer?
No.
101 is not less than 101. 100.9999999999999 is less than 101. That would be fine. But less than means that we're not including the number that we say. So if it's less than 101, it can't be 101. When we have inequalities, we are graphing. When we graph inequalities with a less than or an is greater than, we are not including that as an answer. So it will be an open circle. An open circle means, hey, there's a hole here. There's nothing right here that is part of a solution. So when you see an less than or an is greater than, it is an open circle. Now there are two other inequalities.
I wasn't trying to be funny. Stop.
We have an is greater than and then this line underneath it means that it's or equal to.
Enough.
The other symbol is our is less than with the line, which now gives me my is less than or equal to. This is similar to your parents saying, I'm going to ground you if you get a 70, or I'm not going to ground you if you get a 70 or greater. We are including the 70 as part of our answer. When we graph this, and that's going to be the whole purpose of today's lesson, when we graph this, we are including 70 as part of our answer. So when we do that, we use what's called a closed circle. And it's just a filled-in circle saying, hey, this is part of my answer. Everybody with me still? I need you to step outside. I need you to step outside.
Me?
Yeah.
Okay.
So, when we do this, we have a couple things that we're going to do. First, to graph the variable is on the left. When we're graphing, the variable is on the left. If it's not, we're going to put it there. We're going to see a question that looks like this. Graph. When we look at this, this says x is greater than 2. Give me an answer that x could be that it's greater than 2. What's something greater than 2?
1 or 3.
3. 3 is greater than 2. What about 5? What about 5? Does that work? 6. Perfect. What about 2? Is 2 greater than 2?
No.
No, it's the same. So it's not greater than, so that can't be part of our solution. So when we graph it, we have a number line. We have a 2. We have a 1. We have a 3. Okay, you put 3 numbers on your number line if you're making it yourself. Everybody with me? Greater than is an open circle. I'll talk to you in a second. I'll talk to you in a second. So, is it going to be an open circle or a closed circle? What does it say? Open. Because there's nothing there. It's a hole. That means this is not part of my solution. It's an open circle. When my variable's on the left, only when it's on the left, I can make an arrow. Notice how that arrow points this direction. That means everywhere to the right is a solution. And I shade everything to the right. So let's try this one. X is less than or equal to -3. Make a number line, put a circle on it, let's see what's happening.
Can I have my cousin back? That's all. Where? This?
So, we have our number line. Now this takes a little bit of work because when we have this, we need to imagine that number line in our head. So -3. What's to the left of the -3? What number is smaller than -3?
Negative.
-4. Which means over here is going to be -2. Is it going to be an open circle or a closed circle? Closed, because is 3 less than, or let me try this again, is -3 less than or equal to -3? Is -3 equal to -3? Yeah. So this is part of my solution. That's allowed to be part of the solution. From there, if the variable's on the left, we can make that arrow. It's pointing this direction. So we shade this direction. What questions do we have so far? Okay, so we're going to see one more. To graph, the variable is on the left. So what if I've got 5 is less than or equal to x? Is the variable on the left? Is my x on the left?
No.
No. So when we have this, everything flips. Notice how the greater mouth is eating the x. So when I flip it, that gator mouth still eats the x. Everything flips. Everything flips. This is what we want. We want that variable on the left. That way, when we are graphing, we have 5, we have 4, we have 6. Is it going to be an open circle or a closed circle? Closed, because 5 isn't greater, but it is equal to 5.
How'd you get the other 5?
I'm flipping the entire thing, honey.
I know. But how is 5 equal to 5 if there's only one 5?
Because x is a variable, x is an unknown. We're saying what is greater than or equal to 5? 5 and all the numbers we're going to shade.
But then won't they all be equal?
No. So that first example, x is greater than whatever I put, 3. 3 is not greater than 3. 3 is the same. That's why it's an open circle. Because that's not part of the solution.
But 5 is the same as 5.
And it has an equal sign. 5 is greater than or equal to 5. Is 5 equal to 5?
Yeah.
Okay, that's why this is allowed to be part of the solution. And then this is to the right, and we shade. Okay? You're using these, but the variable needs to be on the left. Do one more like that.
How do you know when you have to flip it?
If the variable's not on the left. If the variable's on the left, you're good. But if it's something like, let's go, this. Okay, when we look at this, we can clearly see that the x is on the right-hand side. Yep? Rather, right?
Yeah.
Okay, it's on the right-hand side. What we need is it on the left. So, what's my gator mouth eating? What's the gator mouth eating? Huh?
The
6.
Yeah, the 6. So it has to stay eating the 6. So I flip these go in the opposite places. It keeps eating the 6. This is now my inequality. We want that variable on the left. From there, we have my -6. We have a -7 and a -5. We have an open circle because 6 is not, or -6 is not less than -6. It's itself. It would be equal to, but there's no equal sign. So this is just saying this is where it starts, but this is not an answer. From there, it's pointed this way. So if I make my arrow, there's my arrow, goes this direction. Questions so far? What questions do you have? Do we feel all right with that?
Can I use
Not
like-
really, not 'cause I don't know.
Hmm?
No, 'cause I don't know it now. And I don't know what we're doing right now.
So we're graphing inequalities. So what we need is the variable to be on the left. Okay, so when the variable is not on the left, we have to make it on the left, which means everything gets flipped. Notice how my gator mouse eating the -6? So when I flip it, the -6 goes in the place of the x goes in the place of the -6. The gator mouth also gets flipped, so it's this way, it stays this way. Less than is an open circle, and the reason why we want the variable on the left is we can take this inequality sign and make an arrow. Which way is that pointing?
Left.
This way, right? All of these numbers are less than -6. Those are all solutions for that inequality.
Okay.
Does that make sense?
Yeah.
So the only other thing that we need to do is go from the graph to the inequality. Isabella, you all right?
Can I use the bathroom when Holly gets back?
Sure. So now I have okay. So I have my graph. I want to write the inequality. So we're going to start with a variable. Choose any letter. It does not matter. What letter would you like to use, Olivia? R. We know that the number is going to be 2. So it's R and 2. Take a look. It's an open circle, which means we're going to choose one of these two. It's either is less than or is greater than. Are the numbers greater than 2 or are they less than 2? Where's that shading? Is it greater than or less than?
Greater.
So all of this shading is to the right. Is 3 less than or greater than 2? Greater. So the answer is R is greater than 2.
Wait, 3 is greater than 2.
It is, but this starts at 2.
Yeah?
It still needs a starting point.
Yeah.
All of the numbers greater than 2 are answers. 3 is one of the answers. So is 3.2, 4, 1 bazillion 200 million is greater than 2. Everything that's shading this way is greater than 2.
Yeah.
So what's your question? I'm confused by what you are asking. No, really, what's your question? I want to help you. So if you're confused, I want to help you. Or do you want to see another one? Okay. So we're going to write another inequality. -3, -2, -1, closed circle, shading this way. Okay. Isabella, choose a letter. Any variable. T. Variables take the place of an unknown value. So we have T. That starting point is at -2.
Yeah.
Okay. It's a closed circle. So this is open circles. We're not going to use these. We're going to use one of these. Which way is it shaded? To the less numbers or the greater numbers? Yeah. So you put this one. And because it's a closed circle, you say T is less than or equal to -2. Would you like to see one more?
I don't get this.
Okay. Which part is struggling? How to start it or how to put the sign? Which part can I help you with?
The signs.
Okay. Okay. Again, doesn't matter what variable we choose. No, it does not matter. I'm going to keep choosing x. What's the starting point? Where is my circle over? 13. Is it shaded to the left or to the right? Left. Okay. Which one points to the left? Is less than or is greater than? Which one points to the left? That's how you get the sign. So x, oh, it's not 12, I'm sorry. Why did I say 12? It's not 12, it's over 13. So it is less than 13. Okay. You do have homework. It's not going to be the same as others did, so give me a second. Okay. I would like you to do you're going to do numbers 1, 2, 11, and 12. That's it. So take a look at number 1. It's giving you v is greater than or equal to 6. Look at your number line. Is there a graph on that number line? There's shading like this?
Oh,
No. So you have to do that. Look at number 11. Is there any shading on number 11? No. What about number 2?
Yes.
Yes, there's shading, so that means you have to write the inequality. So you're either graphing or you're writing the inequality. Again, you're doing numbers 1, 2, 11, and 12. That's it. Okay, go ahead and get started.